Welcome to Wednesday Weather-Wise, and on this week's segment, we take a dive into the science behind wave formation. Now, it's typical that during the late summer, through the fall and winter seasons, and even into the start of spring, when we start to see the wave activity ramp up across the East Coast. This is due to several factors, one being the increased tropical development during the peak of the hurricane season, that being September 10th. When the sea surface temperatures are at their highest, vertical wind shear is reduced across the Atlantic basin, and when there's less Saharan dust out there to choke up any tropical systems. Now, the next factor is large mid-latitude systems that follow dips in the jet stream, most commonly during the fall, winter, and early spring. Now, by following these dips in the jet stream, areas of low pressure will track along the area of that jet stream and towards the southeast United States and form a strong and large fetch of winds over the ocean, which will generate swell in the Atlantic basin from Florida all the way north to New England, which is not only going to increase that rip current risk, but it will also cause beach erosion and also allow for surfers to catch a few sweet rides. So wave formation happens through interactions with wind and the ocean surface. And as the wind blows, the force of friction transfers energy into the water, forming small ripples. Now, as the wind speeds increase, like during a hurricane, for example, those ripples grow into larger and larger waves, sometimes upwards of 50 to even 60 feet. Now, the energy which makes up these waves can travel vast distances, and they can also travel outwards from the source of the wind. Now, the water itself is not actually moving. Instead, water molecules follow a circular pattern up and down, which allows for the energy to be transferred horizontally over these large distances. A great way to see this occur is by watching a buoy in the water. As it moves up and down over the waves, as they pass through, it starts and stops at the same location, and that is where you can see that wave energy being transferred horizontally. Now, once a wave closes in on the shoreline and into shallow bodies of water, it will be able to break over sandbars. Now, this occurs as the depth of the water column decreases, allowing for that height of the wave to increase. Now, since the energy of the wave is being compressed, that's where you're going to see that increase in the height of the column. Now, friction also plays a role in this. As the bottom of the water column slows down due to interactions with the seafloor, now you're going to see the crest of the wave maintain the same speed. And when this happens, the force of gravity comes into play, and that causes the crest of the wave to surge forward and break. And this is very important for surfers in order to catch these waves. This is video that I took myself a couple months back in Jacksonville Beach. This is actually surfing Hurricane Ernesto. If you remember, it was a system way out in the Atlantic, hundreds of miles from the East Coast, and sending its waves all the way to places like Florida, even into the Outer Banks, all the way up through New England. So again, these waves are very important for surfers up and down the East Coast. Without waves, you obviously cannot be surfing. But there is also several different kinds of waves out there, like tidal bores and even tsunamis. And if you'd like to learn more about that, just visit our website, wsav.com.